All right, this is 7.5 more trig equations. So solving an equation, sometimes when you look at it, you're like, well, like this first example, when I look at it, I'm like, well, I got theta on both sides of the equation, kind of like if I had x, x plus 4 equals 3x. I got to get, to solve for x, I got to get x on one side of the equation. Also, what might help me out, notice they're both in, one of them is sine and the other one is cosine. Specifically, look at this one, it's cosine squared. Well, we know cosine squared is 1 minus sine squared. And if we use the distributive property, and then right after that, what I'm going to do is just kind of bring everything over to or to one side. So I'm going to literally just bring things over, and I'm going to end up with 2 sine squared theta plus sine theta minus 1. Now, what to do after that? Because all I've done so far basically is I've substituted here, and then I use the distributive property and set it equal to 0. So remember back in Algebra 1 when you're solving and things equal 0, and think of this as like 2x squared plus x minus 1. Well, what would you do? Well, you would factor this. So this would be 2x, this would be x, and then you would literally just get 1 and 1, and this would be plus and this would be minus, and you would set it equal to 0. And then after you do that, then you take 2x minus 1 equals 0, and then you take x plus 1 equals 0, and then you solve for x. Well, that's what we're going to do here. We're going to factor. This is like a quadratic, because it's sort of, we're going to solve it very similar to that. So it's 2 sine theta, sine of theta, 1, 1. This is the positive, that's the negative. And then we're going to set both of them equal to 0, so literally 2 sine theta minus 1 equals 0, and sine of theta plus 1 equals 0. And then you're going to solve for theta. So, add 1 to both sides, divide by 2, so sine of theta is 1/2. We've had that problem multiple times already. And then sine of theta is -1. So remember, when I'm trying to find theta, I got to sine of theta, I got to think about where is sine going to give me 1/2? Where is sine going to give me 1/2? And so we've already had this multiple times. So this is pi over 6 and 5 pi over 6. So remember, it's positive 1/2, so it's in the first and second quadrants. And then obviously I want all the possible answers, so 2k pi, 2k pi. All the possible theta, that will give me that. So here's all of this. Now over here, where is sine of theta equal to -1/2? Well, again, if you think of the unit circle, the only way we're going to get theta is -1 is right here, right on the unit circle, right at, in degrees, that's 270 degrees, but in theta, that's 3 pi over 2. Right, so theta is 3 pi over 2. And again, we're going to add, I want all theta. All right, so that's solving that equation. And again, go back and look at the steps. All I really did is I switched out an identity, I used the distributive property, and then I basically used Algebra 1 to solve the equation. All right, so let's look at another example. So here I have sine 2 theta minus cosine theta. So again, you got to think of your trig identities that might help you out a little bit. And notice, if you look at the trig identities for sine 2 theta, we're going to literally make that substitution. So this would be 2 sine theta cosine theta. And making that one substitution, you should realize there's a GCF. We're going to factor out that cosine. And then same as algebra 1, you set them both equal to 0. So cosine theta equals 0, and 2 sine theta minus 1 equals 0. And again, you got to ask yourself, cosine of theta equals 0. You got to think, where is cosine, where is theta, where is cosine of theta equal to 0? Well, again, if you look at the unit circle, that's going to come in very handy to go do that. So right here, 0, 1, and 0, negative 1. So we can literally, we know that this is pi over 2 and 3 pi over 2. And of course, 2k pi. 2k pi. And then solving here, we're going to get sine of theta equals 1/2. And we've had this multiple times, so pi over 6 and 5 pi over 6 plus 2k pi. All right, let's look at one more example. So here I have a half angle formula. And so I'm going to start solving for this, and then we're going to use the half angle. So you should automatically notice that. Okay, and then look at the formula for the half angle, because I'm going to be using that sometime in this problem. So if you look at what to do first, we're going to start solving this, and so we're going to get the square root of 3, and 2 equals 1, 10, 2 equals 1 over square root of 3. Now, all you have to do is ask yourself, where is tangent going to give us 1 over square root of 3? So again, think of a right triangle. Tangent is opposite over adjacent, so I want to know, what angle is that? That's a 30-degree angle, or pi over 6. So I know automatically theta, or in this case theta over 2, is pi over 6. And notice that because of tangent is positive, it's positive in the first and the third quadrant, so it really could be over here as well. So we're adding pi k to it. So really got to pay attention. We did this earlier in the last lesson, so tangent is going to be pi k to be able to do that. So that right there is, what this is. We've solved it using algebra, but keep in mind we're trying to find theta, so we're basically just going to multiply everything by 2. So multiplying over by 2, we're going to get, multiply this side by 2 and multiply this side by 2. We're going to get pi over 3 plus 2, 2k pi. I'm going to do that. And if I ask for a specific, like if I say, give me 5 specific theta or 4 specific theta, then you just, then you set k equals 1 or k equals 0, and how many ever I ask you to find, then you would just find how many thetas, specific thetas that would do this. But again, this answer right here is all theta that would work this. And again, you can always check it. These are just equations, so you can literally just take pi over 3, plug it back into the equation up there. So literally take square root of 3, tan pi over 3 divided by 2 minus 1, and see if it equals 0. Okay, so you can literally check it to make sure that it actually works.